Howdy PreCal, it is Ms. Kosh, and we are going to talk about rational functions today. So, as we get started, a rational function is any function that can be written as the ratio of two polynomials. So if I have a polynomial function divided by a polynomial function, we now have a rational function. And so the parent function is just 1 over x. And when we look at that, keep in mind, remember my joke that Chuck Norris can divide by 0? You cannot divide by 0, but Chuck Norris can divide by 0. So on this one, that reminds us, that tells us that our x here cannot equal 0. So that is a restriction in our domain. And what that does in the graph is it gives us an asymptote. It gives us this line that we approach, but will never actually equal. So we have a vertical asymptote at x equals 0. And then we also have our graph, if I have, say I have $1 and I share it with the whole world. Okay, so $1 divided by 7 billion people, it's not 0, but it might as well be. Okay, so what happens is we don't actually ever get to 0, but we're going to get closer and closer and closer to this asymptote. This would be y equals 0. Here's the equation x equals 0. There's that asymptote. So we have a vertical asymptote x equals 0, a horizontal asymptote y equals 0. Our domain is going to be everything except 0. So from negative infinity to 0, then pick it up again, 0 to infinity. And our range is going to be everything except 0 also, because we're avoiding that asymptote. Okay, the domain, it says all roots of the denominator. So we have to restrict. You're not Chuck Norris, you can't divide by 0. So if it is a root of the denominator, then it can't be in your domain. It would be, if you plug that in, so for what example, what we're trying to say, I don't know what just came out of my mouth. Say I have some function and I don't really care what's in the top, x plus 2, and in the bottom I have an x minus 3. Well, if I were to plug in, I cannot let x minus 3 equal to 0. So x cannot equal 3. That is a restriction of my domain. And then this, x equals 3, is an asymptote. Okay, so the vertical asymptotes are the roots of the denominators. Horizontal asymptotes, it depends on if we're top heavy, bottom heavy, or the same degree. So when we're bottom heavy, when the degree of the bottom is larger than the degree of the top, then we have the equation y equals 0. So something like the equation y equals 1 over x plus 5 would have the asymptote, it would have a vertical asymptote of x equals negative 5, and it would have a horizontal asymptote of y equals 0. Okay, if we have the same degree, like this one right here, where I gave you the same degree, this is x to the first power in the numerator and x to the first power in the denominator. I divide my leading coefficients, so I don't care about the exponents, but this 1 divided by that 1 is 1. And so this would have a vertical I lied. It would have a horizontal asymptote of y equals 1. So same degree, we divide the leading coefficient. If it's top heavy, it doesn't have a horizontal asymptote, but it might have a slant or a parabolic or something else. So whenever the degree of the top, so like if I have y is equal to x squared plus 3x plus 2, I don't know, I made something up, over x minus 1, this is top heavy. The degree here is larger than the degree at the bottom, and so this will have a slant asymptote. Okay, slant asymptote's degree of the top is 1 more than the degree of the bottom, and you would have to divide to find it. So if I were to, well, I don't want to do that one right now. Okay, x-intercepts are the roots of the numerator. So if you think about it, if I have, we had this one a second ago, f of x was equal to x plus 2 over x minus 3. If my numerator were equal to 0, if I have 0 divided by, it doesn't matter what I'm dividing by as long as the denominator is not 0. But if I take 0 and I divide it by 2, or if I take 0 and I divide it by 200, or if I take 0 and divide it by 2 trillion, I'm still going to get 0. So the zeros are when I get a 0 in my numerator. So this one, it would have a 0 at x equals negative 2. And the y-intercept is going to be when x equals 0, and so that would just give you the constants. So if I had that x plus 2 over x minus 3, when I plug in 0 for x, I end up with a positive 2 over a negative 3. So this would have the point 0 comma negative 2/3. Okay, holes, anytime a hole is also known as removable discontinuity. Continuity. All of a sudden I forgot how to spell. Whatever. I hate spelling. Removable discontinuity. So if it removes itself from the equation, it gives you a hole. So whenever something is removed from the equation, we have removable discontinuity, we have a hole. Okay, so here's some rules for graphing. Okay, I'm just gonna start graphing. So this first one, I see asymptotes, I have their same degree, so I'm going to divide my leading coefficients. So I have an asymptote of y equals 1. I look at my denominator, and I say x plus 1 cannot equal 0, so x cannot equal negative 1. So x equals negative 1 is an asymptote, we could ask for the domain, but I guess they didn't. The intercepts are when x equals 0, I plug in 0, I get 4. When y equals 0, that's when I set the numerator equal to 0, so x plus 4 would equal 0. That means x would have to equal negative 4. Do I have a hole? No. There is no hole, so I wrote none or whatever, because nothing removed itself from the equation, so we're fine. So now we're going to come along and we're going to draw an asymptote at negative 1. We're going to draw an asymptote at positive 1. And then we're going to put in our intercepts at 0, 4, 1, 2. You know what, you guys, I should have pulled out my reading glasses because I'm not as young as I used to be. Oh, I found them. They're in a drawer. Oh, lovely. You too, one day, will get to have the fun of needing reading glasses. 1, 2, 3, 4. And then I have a negative 4. Negative 1, negative 2, negative 3, negative 4 right here. Okay, and so this is going to kind of show me the shape of that. In general, I would probably actually not give you the grid because I don't want you to have to be precise in all of these points. And so I would probably just want to see this sort of a graph. I'd want to see you've got an asymptote at x. I would like to see that you've labeled this at x equals negative 1. I'd like to see that you labeled this at here's another asymptote at y equals 1. And then I would like to see the point 0, 4 would be up here. And negative 4, 0 would be over here. So labeling those negative 4, 0, 0, positive 4, and that's good enough. And then we don't have to worry about being perfectly precise in all of our points. So I probably won't give you the grid. I'll probably just give you an axis, because then you don't make mistakes, or then you don't have to be as precise. Okay, next one. Dun, 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 dun. Here we go. On this one, the first thing I'm going to want to do is I'm going to want to factor. And so I see that my numerator factors 2. I see a 6, so that's a 3 plus 2. 3 times 2 gives me 6. 3 plus 2 gives me 5. My denominator, I see an x and an x. I see a 2 and a 1. I need the 2 to be positive and the 1 to be negative, so that so I lose I have 2x minus x gives me a positive 1x, and this is a negative 2. Okay. Notice on this one, we have removed those two pieces from our equation. So is there a hole? Yes, when x is equal to negative 2, we have a hole. So what I like to say is that this one will look like the equation y equals x plus 3 over x minus 1, except it will have a hole. It'll have a hole when x is negative 2. So when I plug in negative 2, I get negative 2 plus 3 over negative 2 minus 1. This becomes a positive 1 over a negative 3. So that's got a hole at the point negative 2, negative 1/3. Okay, asymptotes. So my asymptotes come from dividing the leading coefficients. So y equals 1 is my horizontal asymptote. And then I have an x equals 1 as an asymptote. My intercepts, okay, so when I plug in 0 for x, everything is gone except 6 over negative 2, so that's a negative 3. And then I plug in 0 for y. This is a hole, so it's not going to be a 0. But right here, this negative 3, if I plug in negative 3, that gives me a 0 in my numerator. Okay, do you know what? I don't want to graph this on the grid because it's going to get messy, and I already put on my reading glasses, so true story. Okay, so here we go. We have, what do we have? We have an asymptote of y equals 1. We have an asymptote of x equals 1. Oh, you couldn't see. There we go. I'm a little too zoomed in, maybe. Ah, there we go. We can solve our problem. Okay, and then I have intercepts at 0, -1, 2, 3 is going to be down here somewhere, and then a -3, 1, 2, -3, 0. Okay, so that's looking something. Oh, and then I have a hole at -2, -1/3. That's right about here. Okay, and so we're going to pass through this and start approaching those asymptotes, and then we'll also be somewhere over here. And notice what the points that I want to see. This is the point 0, -3, which I had labeled over here. This is the point -3, 0, and here's that hole, -2, -1/3. Those points that I already found, that's what I want to see on my graph, and then I'm going to be in the opposite quadrant of my graph. Super, there we go, looking good. Let's do the next one. Okay, so here I see, I can factor this. This becomes an x -4 times an x plus 4. This becomes an x -2 times an x plus 2. And so my asymptotes are going to happen when x is equal to 2, when x is equal to -2, and then this is the same degree, so I divide my leading coefficients when y equals 1. My intercepts, okay, are going to be when x is 4, we have an intercept. When x is -4, when I plug in -4, this will go to 0, and I'd have all that, now I'm a little too zoomed out. There you go. And that would be 0. And then when I plug in 0 for my x's, these are gone, and I have a -16 divided by -4 is a positive 4. So plug in 0 for x, and I get a positive 4 for y. Do I have a hole? Nope. No holes. Okay, so now I'm going to come back to graphing on just, now I'm too zoomed in. My apologies. Here we go. Okay, so what do I need? I need an x equals -2. I need an x equals +2. I need a y equals 1. Okay, so I've got these two asymptotes. I have the point 4, 1, 2, 3, 4, 0 right here. I have the point -4, 0 right here. I have 0, 1, 2, 3, 4. Okay, and so this is probably doing something like this. And then something probably, well, it's hard to know what this is doing without plotting more points. What do I want you to do? Oh, you have Desmos. I want you to go look at Desmos and see what the basic shape looks like. It's not easy for me to show you Desmos here, but I'll grab a very loud, in my loud drawer is a calculator. Menu, graph. Okay, so delete, delete, delete. Okay, so here I'm going to go graphing this equation. Let's just see what it looks like. X squared minus 16 over x squared minus 4. So notice, I think you should be able to do everything so far without a calculator. Oh, goodness gracious. Let's do window, standard. Okay, and that doesn't surprise me. I kind of figured that it would look something like that, but I wasn't quite sure what was going to happen in the middle. So what it's doing up here is it's going to doing something like that. Super, there we go. Okay. The next one, this one is bottom heavy, so we have an asymptote of y equals 0, and then we have an asymptote at x equals 3. Intercepts, when my x equals 0, this is gone, I get a 6 divided by -3, which becomes -2, and I don't have an intercept. 6 cannot equal 0. If so, I will give you $0 million, and you give me $6 million in return, if you think they're equivalent. Doesn't that sound like a good deal for me? There are no holes. Okay, so there is only that intercept of 0, -2. So I'm going to come back to just blank paper. So when we graph this, I am looking at, I have an asymptote at 3, 1, 2, 3. I have an asymptote at y equals 0. I have a point of 0, -2, so somewhere over here, which tells me that I'm going to be in this quadrant and in this quadrant. And I'm done. That makes me happy. Okay, I think there's more. There is more. Okay. Here we go. I see an x squared minus 4. Okay, so let's see how, on this one, it's top heavy. So we have a slant asymptote. So to find the slant asymptote, we're going to divide. We're going to use synthetic division. There's a 1 x squared. There are 0 x's, and it's -4. And then I'm going to come and I'm going to put a positive 1 outside because we're dividing by x minus 1. Bring down the 1, multiply by 1, add that, multiply by 1. I get a negative 3. And so what in the world is this telling us? This is telling us that that equation, my f of x, was initially written as x squared minus 4 over x minus 1. This is equivalent to saying x plus 1 minus 3 over x minus 1. Okay, because we just took, this is 1x, this is 1, and here's that remainder that we divided right here. So what happens is this graph that they gave us is exactly equivalent to this right here. Well, what's going to happen is x gets ridiculously large. Say I have $3 and I share it with 1,000,000 minus 1 people. Well, if I have $3 that I'm sharing with almost 1,000,000 people, it's not technically 0, but it might as well be. Okay, you're going to get almost nothing out of that. And so this whole term, as x gets ridiculously large, this part goes to 0. And so what we're left with is this line right here. This line is our slant asymptote. So our asymptotes will be y equals x plus 1 from the slant. And then the denominator here, x equals 1, is another, our other asymptote. So let's graph this. Let's see, when I have x equals 1 would be somewhere through here. I am going to use the grid because I want to draw this graph. We have a y-intercept of 1 and a slope of 1, and so I'm doing something like, I like to do this nice little slope with dots because then it looks like a lovely little asymptote. Isn't it pretty? You just love that, don't you? Okay, so here is that intercept. So let's see. In my numerator, if I could set this x squared minus 4 equal to 0, add 4, do the cheer, square root, plus minus, x equals plus or minus 2. So when x is 2, y is 0. When x is negative 2, y is 0. And then when I plug in 0 for x, that gives me a positive 4. So now I have some points that I can plot. I've got 2, 0. I've got negative 2, 0. Oh, sorry, I should use another color. And then I have 0, 4. 1, 2, 3, 1, 2, 3, 4. That was even me with my reading glasses, you guys. Okay, so it's going to start doing something like this as it starts approaching these asymptotes. And then this is going to approach down here, and then it's going to start approaching up here somewhere. Cool? Isn't that lovely? All right, there we go. Una más. Here is our last one. On this one, I go to factor. I can factor out an x. And this is the difference of squares, so x minus 3 times x plus 3. Ah, I see something that's going to remove itself from the equation. So this is going to look like, y equals x over x minus 3. However, it's going to have a hole when x equals negative 3, because this right here would be x equals negative 3. So plug in negative 3, I get a negative 3 over a negative 3 minus 3. That's a negative 3 over a negative 6. The negative divided by negative is a positive. This is a positive 1/2. Okie dokie. My asymptotes, okay, so it looks like this. So I have an asymptote. I'm going to divide the leading coefficients, y equals 1. And then I'm going to have x equals 3 as another asymptote. My intercept, when I plug in 0, well, I'm going to have the point 0, 0. And when I plug in 0, yep, I get 0. Okay, there we go. Yes, set this equal to 0. We're just at 0. And let's go ahead and, do I want to graph it on here? Not really. Okay, let's do it this, let's jump down. Let's let you see a little bit more that's happening. There we go. Okay, so if I graph here, I have an intercept, an asymptote of y equals 1, an asymptote of x equals 3, and an intercept of 0, 0, and a hole of negative 3, 1, 2, 3, negative 1. So right here, I've kind of tried to make that a hole. And so we're going to do something kind of going through those points, and then we're going to do something over here. Isn't that lovely? There we go. All right. Like, subscribe, comment, let me know how I can help you. And the only way to learn math is to go practice. So go practice.